Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Sumerian star knowledge. Did the ancients know the solar system? Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In the Museum of the Ancient Orient in Istanbul, there is a clay cylinder seal dating to approximately 2500 BC that appears to show the sun surrounded by 11 other celestial bodies, arranged in a pattern some researchers interpret as the planets of our solar system, complete with a large outer body that might represent a planet not officially discovered until the 19th century. In the library of the British Museum, among the thousands of Sumerian and Akkadian cuneiform tablets from Mesopotamia, there are astronomical texts that describe the movements of celestial bodies with a precision that surprised modern astronomers when they were first translated. The Sumerians are generally credited with the invention of the sexagesimal number system still used in our measurement of time and angles, with the development of positional astronomy, and with the creation of star catalogues that provided the foundation for all subsequent ancient astronomy. The question is whether their astronomical knowledge was merely observational, tracking visible objects, or extended to knowledge of planets and structures beyond what the naked eye can easily observe. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the wider world of ancient technological anomalies, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Out-of-place artifacts, objects found in geological or archaeological contexts that predate their supposed invention, represent one of the most contentious categories in all of science. The scientific establishment's response to such discoveries has historically fallen into two camps. The first is skeptical investigation, careful re-examination of the dating, the context, and the object itself, which often reveals a mundane explanation. The second, rarer response is acknowledgement, a formal revision of the assumed timeline in light of evidence that cannot be explained away. Both responses have legitimate roles. The history of archaeology includes many cases where enthusiastic amateur discoveries of supposedly ancient anomalies turned out to be forgeries, misidentified natural formations, or artifacts simply displaced from their original layer by post-depositional disturbance. Critical scrutiny of extraordinary claims is not closed-mindedness. It is scientific responsibility, but it must be applied consistently. The same rigorous scrutiny applied to anomalous claims must also be applied to the mainstream assumptions those claims challenge. And sometimes, when the evidence is examined honestly, the mainstream assumption is the one that breaks. The significance of genuine out-of-place artifacts goes beyond the objects themselves. Each one represents a data point in a larger argument about ancient human capability, about what our ancestors understood, what they could engineer, and how much of that knowledge has been lost. The ancient world was not populated by primitive minds in primitive bodies. The brains that looked up at the night sky 40,000 years ago were neurologically identical to ours. Given sufficient time and motivation, they could have discovered and lost almost anything we know today. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, Let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding Sumerian star knowledge. Did the ancients know the solar system is more extensive, more verified, and more troubling for conventional explanations than most people realize? Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail: Sumerian astronomical texts, including the Venus tablet of Amisajuka, dating to approximately 1700 BC, record the heliacal risings and settings of Venus over 21 years, with accuracy consistent with careful long-term observation. This required systematic record-keeping over generations and demonstrates sophisticated astronomical practice far earlier than previously recognized. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the Mul, Apin tablets, compiled around 1000 BC from earlier Babylonian astronomical records, contain detailed descriptions of constellations, star rise and set times, planetary movements, and ecliptic positions of celestial bodies. Modern astronomers have verified that the positional data in these tablets is accurate to within degrees, achievable only through systematic naked-eye observation over centuries. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine cylinder seal VA/243 in the Berlin Near East Museum, dating to approximately 2500 BC, shows what appears to be a solar system diagram with the Sun in the center, surrounded by 11 bodies of different sizes. Researchers at Cheria Sitchin interpreted this as depicting all 9 planets plus the Sun and Moon, implying Sumerian knowledge of the outer planets not discovered by modern science until the 18th and 19th centuries. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Sitchin's interpretation of the seal is not accepted by mainstream Assyriologists, who argue the central object is a star, not the Sun, and the surrounding objects are other stars in a star cluster, a common astronomical motif in Mesopotamian art. The number and size of the bodies in the seal do not clearly correspond to the planets of our solar system. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of Babylonian astronomers, the successors of the Sumerians, developed mathematical models for predicting planetary positions that were extraordinarily sophisticated. A Babylonian text from the 6th century BC predicts the precise date of a lunar eclipse over 400 years in advance. This required mathematical astronomy of a caliber that was not matched in Europe until the Renaissance. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. The Sumerians recorded a planet they called Nibiru in their astronomical texts, which has been interpreted by Sitchin as a large undiscovered planet on a 3 600-year elliptical orbit. Mainstream Assyriologists identify Nibiru as a standard Babylonian term for the planet Jupiter or for a specific point in the sky associated with celestial boundary crossing, not an unknown planet. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Sumerian star knowledge. Did the ancients know the solar system? This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Sumerian and Babylonian astronomical knowledge was derived entirely from sophisticated naked-eye observation conducted systematically over centuries, representing the most advanced observational astronomy of the ancient world, but not implying knowledge of bodies invisible to the naked eye. This is the mainstream scholarly position, supported by the mathematical nature of the astronomical texts, which are clearly record-based rather than revelation-based. This interpretation has significant academic support and is backed by substantial evidence. But it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that ancient Mesopotamian astronomical texts preserve knowledge from a previous era of human civilization that had access to optical instruments or astronomical knowledge from an advanced source, potentially extraterrestrial according to Sitchin's Anunnaki hypothesis, or from a lost terrestrial civilization according to others. This interpretation requires acceptance of Sitchin's cuneiform readings, which are not accepted by professional Assyriologists. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that Sumerian astronomers developed mathematical extrapolation techniques sophisticated enough to predict the existence and approximate positions of outer planets from perturbation effects on known planetary orbits, achieving through mathematics what the telescope later confirmed visually. This does not require supernatural or extraterrestrial knowledge, only extraordinary mathematical capability. What is striking about this debate is not merely that experts disagree, that is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Sumerian star knowledge, did the ancients know the solar system, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the Venus tablet of Amisajuka, independently verified by modern astronomical calculation. Records Venus's appearances with an accuracy demonstrating genuine systematic observation over at least 21 years, direct evidence of the sophistication of Mesopotamian astronomical practice. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented. Babylonian eclipse prediction texts have been independently verified against modern computational astronomy and found to be accurate, confirming that the mathematical models developed in Mesopotamia were empirically reliable rather than mythological. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the mathematical structure of MUL. A pin and related Babylonian astronomical texts reveals a tradition of systematic, quantitative observation spanning centuries, an institutional astronomical practice with no clear parallel elsewhere in the ancient world of its period. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Sumerian star knowledge. Did the ancients know the solar system? Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Babylonian astronomy is now recognized as the foundation of Western mathematical astronomy, transmitted through Greek scholars, including Hipparchus, who used Babylonian eclipse records to calibrate their own observations. The sophistication of Mesopotamian astronomy, once underestimated, is now acknowledged by historians of science as extraordinary. The fringe claims built on top of this genuine achievement, undiscovered planets, extraterrestrial teachers, are not supported by the cuneiform texts. But the genuine achievement is remarkable enough on its own terms to be worth investigating without the embellishment. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Sumerian star knowledge. Did the ancients know the solar system? From the historical record, through the physical evidence across the competing theories, and into the modern significance of what remains unresolved. What the story of Sumerian astronomy ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process, and the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.